Greetings, Sightseers. Today we're going to talk about power generation and using latching circuits to run our generators until our batteries are full and then turn them back off. So let's get started. First thing we want to look at is the design of the system and the purpose for its being. As you guys know, solar panels are a great way to run your base as long as you have enough panels to actually provide the power you need. My little outpost here isn't generating quite as much power as it needs, so we're slowly running our battery down all the time. There are some ways we can solve that. We can add more solar power. We can use geoelectric power. Turns out my geoplant can help keep our base running by the day, but at night, it's still not enough to keep up with demand. So what we're going to do is we're going to add an ammonia plant. We've been gathering ammonia. We're going to add an ammonia plant into our mix in order to generate emergency power at night. This also will help us if we run into situations where we need to run our beam turrets or something like that because we're under attack. The ammonia plant will be able to kick in and keep our batteries charged. So as you see, we already have a battery pack here. The battery pack is slowly being discharged by our by the things we have consuming energy. So let's get started. First thing we want to do is we're going to set up some resource sensors and we're going to set up some frequency sensors. We need 2 electric sensors. We're going to configure the first electric sensor so that it turns on when our battery pack is below 25% charge. So let's go ahead and do that. We're going to go to the build menu. We're going to go to our sensors section and we're going to get an electric sensor. And let's put it on our little stage here. And we're going to go in and we're going to set the frequency to 1000. Resource is already at electricity and we want this to trigger at 25%. So when the battery pack gets below 25% charge, we're going to trigger with. And as you can see, we're already below. So what did we do wrong? That's because we did this backwards. Below 25% charge. Ah, there it is. So anytime we're below 25%, you see the light on our resource sensor comes on. So that's not enough, of course, to trigger our power. I mean, that could trigger our power plant to run, but we're going to go a step further than this. We only want the power plant to run until we've charged back up, and then we want it to turn off again, and we want to cycle our battery again. So the second thing we add into this is we add a frequency sensor. We're going to listen on 1000, the same thing we set let's actually try 1000 and not 100. This is the same thing we set the transmitter over here to, and you see the green light came on. The catch is we need to set the above and below so that they're not at the minimum or the maximum. You notice we set the output on this electricity sensor to 50% so that it does not actually send a full signal. The reason for that is we're going to send a second signal when our battery pack is full, and that signal is going to be 100%. And that's going to tell us, hey, turn this whole thing off. So that's the second fun part of what we're going to do here is we're actually going to feed the frequency sensor with its own output. And so we're going to set the frequency sensor to 50. And what that will do is, since that's inside the range here, that's going to cause our frequency sensor to stay running. Even if we turn off the signal on the input side, you notice the frequency sensor stays on. Okay. We're going to use a second frequency sensor. Also listening at 1000. That, and again, we need to keep it below something less than 100 on the below side. What this is doing is this is taking our input signal from the latching sensor, the second guy, and that's boosting the signal 100% so that our power plant runs at full power. See, our utilization on the power plant is 100%. We could have had the power plant running off of our latch, But notice what happens. It goes to 50. We don't want that. We want it to run at 100. And then again, why is that? That's because our latch is only putting out 50% signal. So we're going to run that at 100. Finally, we need a way to trigger when the battery pack is full. Now the battery pack is charging. It's going to take a few minutes, so we'll the last sensor we are going to install is going to be our full sensor. We're going to set this to 95. This is going to put out a signal on 1000 when the battery pack is full. What that should do is that should cause the latch unit to turn off because it's receiving too much signal. When we receive 100% signal, this below is going to be false, and then that's going to switch us over to the inactive. Once we're no longer putting out an active signal, we're no longer going to be receiving an input, and the latch is going to stop. We're going to fake this for right now. We're in creative mode, so we're going to fake this by filling up our battery pack. And if you guys are watching, you saw what happened. As soon as that light came on, this light turned off. This is our latch. Our relay also turned off, and now so now what's going on? We're getting power cycling here. That's because some dummy, namely me, forgot to set the low side. We gotta always set our above 0 to prevent cycling. There we go. To prevent oscillation is the correct term. So now we're sucking that power down. As you see, we're sucking it down pretty quick. We're sucking it down quicker than we're generating it, that's for sure. Since it's nighttime, we don't really have much generating. Our solar panels aren't working. We're gonna shut down our geothermal plant in order to give us a quicker drawdown on our battery. See, our battery is getting drawn down pretty quickly, and when it gets down to 25%, we're gonna see the start button turn back on again. So to recap, our start button, our start sensor needs to be above 0, below 25, and put out an active signal of less than 100%. Let's just call it 25. So 0, 25, 25. Our stop button needs to put out 95, 100, 100. And then our latch needs to be something above 25, below 75, and active 50. This will, again, with the frequency, the same listen frequency as the transmit frequency. This will cause the latch to cycle on and then stay turned on as it's hearing its own input. And there we go. The input came on, latch came on, relay came on. Now we're going to start generating power. Our storage is going to get somewhere above 25%. And again, notice that when we got above 25%, our start sensor turned off. But now that the cycle has been started, it will stay running for as long as we have, as long as our input is less than 100%. Now, that is the complicated way to do it. There are simpler ways. Let's say you want to, excuse me, let's say you know that you want your generator to always run for, say, 5 minutes, a minimum duty cycle of 5 minutes. You could use a timer. So the latch circuit is great for situations where you want it to run until your battery is full, and then shut down. You could use a timer for shorter processes. So let's go ahead and explore how to use a timer. I'm going to put a second ammonia plant in here so that it charges the battery faster. Great, it's charging nice and quickly now. So now, when might I use a timer? A timer could be used for something like keeping a gate open. Let's say we don't want a gate to close. Ideally we want a gate to close after someone has passed through it, but we might want to give them a chance to drive away from it before we. Or we might want to run an extractor or something else for a period of time. So let's explore timers real quick. We could also use timers, by the way, to run our generators for a specific period of time before shutting down to prevent short cycling. In this case, let's go ahead and do that. Let's go ahead and run our generators. So we got everything back off. I'm going to disable, and I'm going to disable our full. So the only guy that's still going to be on is our start button. Now let's add a timer. That is the timed sensor. Time sensor is going to serve largely the same purpose as our latch, but we're just going to set a specific amount of time for that to run. I want our time sensor to always run for 5 minutes. 5 minutes is 300 seconds. After it apparently we can only run for 1 minute. So I want our time sensor to run for 1 minute after it gets a signal from our input. So we're going to listen on 1000, and we're going to put out 1001. Just going to go ahead and be active at 100%. It's going to be inactive at 0. I'm not going to worry about those. Okay. So now the timer is just going to run for 1 minute no matter what. Now we're generating 120 power. The capacity on this thing is 500. So 120 over 60 seconds is actually, that will fill this battery up in about a minute, in less than a minute. Much less than a minute. So we can actually just let that thing run on a timer. Now the question is, what happens if we have 2 batteries or 3 batteries or 4 batteries? That's where we want to deal with that's where we might want to use a latch circuit to make sure the battery always receives a full charge. So 31, 30, 29, and there went our starter. Starter turned off because we got above 25%. Our timer is still on. And our timer is going to run, and it's going to run for a minute as it refills our battery. Unfortunately, we don't have any sort of any way to see what the actual ticking is on the timer, so we're just going to have to trust that it's working. Now, the downside of using a timer is that we're going to run those generators even after our batteries are full, because we don't have any way to know that we don't have any way to know that the generators are full. There are a couple of ways we could mitigate that. For example, we could go back to using our latch and our second sensor over here to shut the generators down, and then see, there it went. So apparently we're using power quicker than we're quickly enough that we don't actually fill the generator up. So a minute of running doesn't actually quite fill the generators up. So that's how the timer circuit works. We can also use the daylight sensor to run our generators only at night. We could use our daylight sensors to only run the lights at night. Let's go ahead and do that. I don't yet have lighting, so let's go lighting. Let's go 120 as our frequency for lighting. So all of our lights will turn on at 120. So we're going to turn the lights off during the day with our light sensor. 120. Oh, what just happened there? Oh, that's because the light sensor is active when there's sunlight and inactive when there's not sunlight. So, there we go. Let's go ahead and flip that around. So now, when it's dark, you're going to use the inactive to run the lights. So you see how you can flip the signals around to do things. So we're actually going to run this backwards by using the by reversing the active and the inactive. You see all the base's light now comes from that light sensor. And we'll test the light sensor by turning the lights back on. Oops, that was not what I wanted. Let's go back to our commands. This sets the daytime. See our lights turned off. We're not sucking as much power down now. We're generating power from our solar panels. Still not quite enough to run everything all the time, but enough that our generators will cycle less often. So you see there's different ways to run your generators. You can use this latch circuit, which listens to itself. You can use the timer circuit, which you can set up to 1 minute of forced on time. Or you can do things like use a daylight sensor to run your generators at night and run your lights at night as well. So I hope this has been informative and interesting. Have fun.